are supposed to graph what are called the inverse functions. Now, we've talked about reciprocal functions. We talked about, like with cosine, for example. The reciprocal function is what? Secant. It's when we just flip the fraction. It's just another fraction of sides to sides in a right triangle. What if we want the inverse function? If you remember what an inverse function is, you take and you put a value in a function, and the inverse function takes that value and spits back out the original value to you, okay? So it's a way to get back to where you started. If you put a number in a function, the inverse function is going to undo what you just did, just like adding and subtracting are inverses of each other. So cosine and arc cosine, and by the way, they could write arc cosine or they could write it this way. Let me write it in red up here at the top so you'll see where I'm doing it. When you see this, that's another way to write arc cosine. Cosine, and it looks like they're putting it to the -1 power or something. That means the inverse function. It is not flipping it. It's not the same thing. It's totally, basically, if you think about cosine, I graphed it down here at the bottom. If you look at, like if I took the value of 0 in radians, if I put it in the cosine function, I'd get 1, right? So if I want to get 1 back, if I want to get back to the 0, let me shut that door. What the arc cosine would do would be, say, if somebody tells me that I've got a cosine value of 1, or if I put in a value of 1, it would give me the angle back out. It would give me 0 degrees. So if I were graphing that at 1 on the arc cosine, basically, do you remember with inverse functions that you can just take the tables and reverse the points and you get back? You know, that's how you can graph them. Do y'all remember doing that? I don't know if you do or not. With inverse functions, if this is my cosine table over here and I want my arc cosine table, I'm going to put in an x value, for instance, and what I'm going to get out is going to be my arc cosine. All I got to do to build this table is just flip the points. If I have 0, 1 over here, it's going to be 1, 0 in the arc cosine table. If I have pi half 0, all I'm going to do is flip the x and the y values. Do y'all remember that that's one way we graph, like logarithms, for example? We didn't have a way to go graph logarithms like log 2x, so we just took the exponential function and we reversed the points, and that's how we graphed it. And that's what we're going to do here. So I would have pi -1 would become -1 pi, and 2 pi 0 would become 0, 2 pi. Now you might notice there's a problem with this table, the green table. Do you remember that in order to be a function, each x can only have one y? You have something up there. You've got 2 of the same x's with different y's. So that would mean this would not be a function if I graphed it right now the way it is. So what I do, since we want to talk about the function arc cosine, we just restrict it to certain values. So if you this is on page 322 in your book at the graph you're looking at. Here's what we do. We say, okay, where would I be able to get an example of all the different values that I could get, okay, in the arc cosine? And so if you look at on page 260, they kind of tell you this is what's usually done. You go, okay, I'm only going to take a domain for the arc cosine from -1 to 1, and that kind of makes sense. If I'm looking at this function, really if I could take this function, I could slide it sideways, I'm going to get a picture of what my arc cosine is going to look like. I only want to take a portion of it, and so what they do is they take from here to here. Wouldn't cosine hit all of its values between those two? It's up at 1, it's going to drop through 0, and it's going to go to -1. That would be right there where it's hit at least one of every value it could be. So if I take this little thing and I twist it on its side, that's what the arc cosine graph is going to be. So what we're going to do is we're going to, okay, let's look up here. If I only want one of each value, let me cut this 0, 2 pi out. And for my arc cosine table, I'm just going to look, I'm going to have a domain, I'm going to only look between -1 and 1. So if I, remember that my range on my previous function becomes my domain on its inverse function, just because we flipped the points. The y's become the x's become the y's. So what I'm going to do is this, I'm going to say, okay, I've got the point 1, 0. So here's 1 and here's 0. I've got the point 0 pi halves. So 0 pi halves, we're going to take it, here's pi halves, okay, up here. So 0, you're up at pi halves. Oops, I shouldn't have gone that far. Let me go ahead and extend it up. It's kind of like if I start over now, it's going to take me forever to rewrite all this. And then at -1, I'm up at pi, and that's where I messed up. I should have made that first mark that I call pi halves pi. So at -1, I'm up at pi. Let me do that in a color that'll stand out. So here's a point, here's a point, and then at -1, I'm up at pi. And so if you kind of connect these, it kind of does a little curve like that. That's all we're going to graph of the arc cosine because we need it to be a function. And it's not going to be a function if I graph the point 0 to pi. That would put it, let me show you where that would be. It would be up here, and you could see that it would fail the vertical line test is what I'm getting at, okay? We only want a function, so we have to restrict the values we plug in for x in order to get it to be a function. Otherwise, because this thing repeats, we'd have a big mess if we tried to graph this, okay? If you look on page 322 in your book, you see there's the graph for arc sine. And again, all you would do is you would take some sine values, you would flip the x and the y's to get your inverse table, and you would graph from the table. Okay. I had a slight moment of panic when I looked at 11 because I thought it said don't use the graphing utility. They don't want us to use the graphing utility to plot the graph, but they did say if you look on A, use the graphing utility to complete the table. And I'm thinking, how are we supposed to do that? Because they gave us these values that aren't nice. Like if they'd given us square root of 3 over 2 and square root of 2 over 2 and stuff like that, we could have actually not used our calculator and done this because we could have worked backwards from what we know about right triangles. But here it did say use our calculator. One thing you need to know about the calculator, first of all, we're working in radians. Almost always we work in radians with these inverse functions here. If you want to get to the arc cosine, you have to hit your second button. And we did a little bit of this in geometry. I just don't know if you remember it. And you have to hit your cosine button because above your cosine button it has that cosine -1. It has this notation up here that I told you that I wrote in red. So that's how you're going to get to it. And then you're going to enter the value. If you think about the arc cosine, what's happening, if we take the cosine and we take an angle and we get its cosine value, we get its little fraction. Now we're putting the fraction in, and the calculator is going to tell us what angle that is, basically. Okay, so if we wanted to make this go faster, we could go in the calculator and we could go to y equal, and we could put second cosine and then just put x in there. So what I put in the calculator, because I'm thinking this is going to be easier than doing all that punching, is this. And again, to get the cosine -1, I use those keys there. And then I'm going to go to my table set and I put it on ask so that I can just type these values in. So then I'm going to go to my table and I won't have to do all that punching. I can just type in the number, okay? So let's see, if we fill out our table, -1, okay, x is, let me make sure I did that right. We know what -1 should be. Look at our table. At x is -1, it should be pi. So from our table, we should get that. What's making me a little concerned, -0.4, we're getting 1.98. -0.2, we get 1.77. And then a 0, this should be a recognizable one because we know it should be pi halves. We get 1.5708. Now, since we know what that really is, that's one of those major points that we graphed at 0. 1.5708 would be pi divided by 2. Okay, so let's just go ahead and put pi halves because at least that's it is 1.57, but that's really pi halves. We can kind of graph this thing from using our major values, like from our unit circle. We just have to kind of tweak what we do, with it. So let's go ahead and call that pi halves, even though we could call it 1.57. Okay, so for point 2, we have 1.5708. 0.37 if we round. For 0.4, we have 1.16 if we round. For 0.6, 0.9273. Well, it should be 0.93 if I round. I forgot to round. And then 0.8, we get 0.64, we round. And then for 1, we get 0. Now if you look, my guesstimation of my graph, just from switching my points, has all this on there, doesn't it? It's just that there's more there. And so for 11, what they were wanting you to do is plot the points in the table and graph it. We kind of graphed it by reversing the points. I'm not going to make you go back and do all these little points. You don't have to go back and graph all these, but do you see that we could get even more accurate if we wanted to here? You'd probably want some really good graph paper if you were going to try to graph this. So